Okay, good evening, everybody. Welcome to the January meeting of the Wrekin branch, IAgrE. And this evening we have a presentation talk by Robert Turner. Robert is a metal conservator, architectural conservator, should I say. And as you've sort of probably read in the sort of circulated poster and that, he's worked on quite a diverse sort of different sort of areas and that, sort of ranging from sort of the Albert Hall and the SS Great Britain and that. So yeah, I will hand over to Robert and give him the floor. So thank you very much. Over to you, Robert.
Good stuff. Right, thank you. Welcome, everybody. Yeah, tonight's talk is going to be somewhat varied. It's the mundane and the monumental. Hopefully not too much mundane, in fact, but there might be a little bit. I don't need to dwell on this slide for too long. The chairman gave me an introduction. I'm pretty much retired, I have to say now, so the only thing I do now at the moment, I mentioned today, is a little bit of work for the European Commission, but it's few and far between. So the aims of the presentation, well, almost everybody I've ever come across has some idea of what they mean by conservation. Usually it's to do with nature conservation, David Attenborough and people like that, rather than my kind of conservation, which is really to do with the built environment, objects, monuments and things like that. But also I'm really known probably as a macro conservator, and that is slightly different. So what is conservation? Well, our main aim really is to try and treat every object individually. And I'm sure all of us who ever do anything that's very, very nearly a repeat of something that they've done before are tempted to fall back on the tried and the tested. And there's nothing wrong with that in many ways, actually, because if you're doing that, you know exactly what the problems might be, or at least most of them. You're familiar with the processes you need to go through, and you can usually be more efficient. However, but you do that at your peril when dealing with strange objects, some of which you won't have seen before. So it behoves you to actually look very carefully at each object before deciding exactly what you're going to do with it. And that's particularly true of larger structures, I would say. The next thing that we're very keen on is documentation. And we kind of joke within the profession that we spend most of our time undoing the best efforts of our grandfathers. And that's very difficult in the absence of documentation, because you have to try and work out forensically what it is that they've done, so that you can try and undo it if need be, without doing any further damage, assuming that they may have done some. Our next principle is reversibility. So whatever we do, we would really like to be able to undo without doing any damage at all. There's a bit of a caveat on that, though, because as somebody once quipped, to do nothing isn't necessarily irrevocable. So you shouldn't do nothing if the object absolutely needs something. But you should also strive for minimum intervention, and minimum intervention really, you'll probably achieve it by looking at reversibility, actually. So you do the absolute minimum to achieve the ends that you need. Macro conservation, well, that's really just a slightly grand term for doing the above things, but usually with large outdoor objects, objects that many people would say probably should be put in a museum, but for whatever reason, either they're too big or too precious in their environment, so they can't be. So it's always nice to start off with something that people might recognize. Now, those who live in the Wrekin area may well recognise this piece of sculpture outside the entrance to Birmingham Bullring Shopping Centre. Admiral Lord Nelson. We had the privilege, if that's what the word is, to be having to remove him and his plinth before they could start work on the revamping of the Bullring Centre, however many years ago it was, and then put it back right at the end. Nelson shares the accolade of being the very first public sculpture of a non-royal to be built by public subscription. It's just a sign of how fond the Georgians were of their hero. In the same centre, this is a modern piece and probably even more popular than Nelson. It's simply a modern representation of a bull, very appropriate in the boarding centre. But I can assure you that this piece of sculpture is absolutely loved by the shoppers who visit the centre. This little girl being one, and her sister, and her mum obviously enjoying the process herself and recording it for posterity. The shopping centre people debated long and hard about whether to put some kind of protection around this statue, as indeed there was around Nelson, who had a very formidable set of railings built around him to keep people away. But in the end, they decided not to, because it's clearly very, very important to the people who go there. The downside is that there's the possibility of damage to the sculpture, both structural, and our only involvement, in fact, was working with the sculptor and the foundry to put some strengthening in that part to try and make sure that it didn't get snapped off. What we couldn't do was to protect the surface. And here you can see the kind of scratching that presumably modern trainers cause when people are trying to climb up onto the back of the bull. And even though the whole thing is in a protected environment, you can see that where the brown coating has been scraped away, there's a sort of light green coating forming, which is probably copper sulfate, and it's the bronze ever so gently corroding. Not only are the people of Birmingham fond of climbing on their statues, but so are those in Aberdeen. And I heard there was somebody from Scotland, at least one member from Scotland, who's visiting us this evening. This is a good piece of Aberdonian wit, as you can probably see around here. At the end of a cigarette was put in this woman's mouth, which on the face of it is not causing amazing amount of damage. It's certainly not scratching the patina. It's not causing any damage to the lips or the sculpture itself. However, if you look further down, you might just be able to see that the statue itself has moved on its plinth. And the bottom of that statue is probably only about 20 millimeters wide. So it's quite close to falling off its plinth. And had that happened, there would be probably about 3/4 of a ton of bronze falling over on whoever it was climbing on it to try and do whatever it was they wanted to do. So we had to lift it and anchor it back in position. This monument is suffering much more damage and not man-made. You can probably see from that overall picture, there's quite a lot of green staining on this stone below the angel. We can see on the angel's face that something is happening. There are two forms of obvious corrosion going on there. The light green is copper sulfate that is fairly portable and will wash off, and the sulfides are strong and crusty and stay in black patches. It's obvious at the lower part of the statue that other corrosion is taking place as well, because as well as the green that we can see washing down, there are rusty brown stains, and indeed rust is what it is, as we will see later. When we got back to the workshop and we started to take the piece apart to see what was going on. Now, for those of you who don't know about the casting things like sculpture, basically the process is to make your model of the angel of peace, either in clay or plaster of Paris or whatever material you want that is relatively stable. And then you take a plaster cast of that. So you end up with a female version of the thing that you have modeled up in the first place. Now, you could just pour your bronze straight into that if you wanted to have a solid bronze statue, but it would weigh an awful lot and also cost an awful lot of money. So they always put core material in there so that they would then fill the statue with core material putting a material that was sacrificial of, say, 1 centimetre, 1.5 centimetres thick all around the inside of the mould, so that you then ended up with a bronze casting of that sort of thickness. And the foundries should take out the core material and any supporting elements that might be in there, because if you don't do that, you tend to get corrosion going on inside your statue. However, quite often the foundries were a bit lazy, and they didn't take it out. And in this particular case, as you may see here, there are some fairly substantial pieces of ironwork running up inside the statue. And these were not to do with supporting the core, they were more to do with supporting the statue. However, we needed to get rid of this because otherwise the corrosion would continue and sooner or later the statue would have fallen down. When we excavated the core, we found all of these pieces of loose, pretty loose pieces of ironwork inside. But it was clear that there was more because we could see ironwork going down into the legs. And here you can see, and this is an iron bar that thankfully hasn't corroded much. But that was clearly put in place with no core material around it. So when the bronze was poured into the molds, it solidified around that and gripped it. And in fact, what was happening was that the ironwork was going up inside the body of the statue and into the wings to provide some support for which was it was quite a large statue and obviously had a fair amount of windage in its elevated position. Having taken it out, which as you can probably see from the photos was not an easy job at all, we then had to replace it, which we did with stainless steel. And then stainless steel going up inside the statue, screwed, bolted, and then welded back in place. Now, I said before that you could see the various coloration on the statues, the green and the very dark black. The statue itself started life as a sort of nut brown, and that's a very, very common finish on Victorian Edwardian statuary. It's an artificial coating that's put on. It's a chemical process that corrodes the surface of the bronze. And if the bronze was kept in, say, your dining room, it would be pretty stable. And that nut brown color would stay as long as you didn't rub it too hard, being overzealous when cleaning it. That nut brown finish would be there pretty much forever. However, if you put it outdoors, particularly in the era of acid rain, then that coating very quickly disappears. Of course, we then have a debate with our clients as to what they would like their statue to look like when it's returned. Probably not like that, and certainly the lower part couldn't be like that because of the work that we've done to it. So we repatinate, and we repatinated simply using chemicals which produce a coating of a couple of microns that provide the color. So that's what it looked like when we picked it up. That's what it was like in our workshop once we repatinated it and waxed it. And that's what it looked like when I was in Norwich a couple of years ago. And you can see that the process of turning green is very slowly beginning again. And the only way to stop that is to get up there and keep waxing, which is an expensive thing for local authorities to have to do. Closer to home for Wrekin members, this is Clive of India in Shrewsbury, another one that we did a few years ago. And again, it shows quite clearly the patinating process. There he is outside the workshop, and there he is at the moment, I hasten to add, on his plinth in Shrewsbury Town Square. However, there's a big debate going on, as there was in Birmingham, in fact, with Colston, another one of our statues, as to whether he should stay there or not. And at the moment, it appears that probably an interpretive plaque is going to be placed nearby and he will stay. But it's a big argument these days as to whether these things should be out there in public view or put in museums where a more measured discussion about their meaning could take place. A complete change of topic now. Those, and I saw there were one or two members in the audience of my generation, may be able to cast their mind back to the day that Bob Dylan started to play electric. And when he did it in Manchester Free Trade Hall. And it was a very, very notable concert for those who are traditional folkies and those who are more modern. Well, it's pretty notable for them as well. Anyway, the point is that below the stage in Manchester Free Trade Hall, there was a kind of a large room where artists used to wait before going on stage. And the stage manager encouraged everybody who performed there to sign their name on the wall. So he'd give them a pen or a pencil and they'd write their names on the wall. That stage manager retired and somebody else took over and walked down there and said, "What a mess, paint it please." So it all got painted apart from 3 panels where there were posters screwed to the wall, which had obviously been put on after certainly these people had signed the walls. So they didn't get over painted. And then some years ago, it was decided that the old Free Trade Hall was going to be pretty much demolished and a Radisson Hotel built there. And so souvenir hunters went in and took the posters that were screwed to the wall, revealing these signatures, at which point a local councillor thought it would be a good idea to have them spot listed, which was duly done, which meant that the developers couldn't proceed with their development of the place until these signature panels were saved. So we saved them for the contractor and for the developer. So they're now on display in this hotel. But they're not very large, so it was a fairly simple job for us to do. But the main contractor approached us and said, could we do something similar for something like this? Now, this is a Dalton tiled panel that was in the Royal Victorian Infirmary in Newcastle on Tyne. And they said, we're going to demolish this hospital and build a new one. And we have to save 6 or maybe 8 of these panels. Do you think you can do it? And we said, probably yes, but we need to go and have a look. So then when we went to have a look, we arranged to go and have a look, and somebody said, no, actually it's 8, it's probably 8 of these panels. And then when we actually got there, they said, no, it's 68. And then eventually it turned out to be 86. So yes, we said, we thought we could probably remove these 86 panels safely. And the traditional way of removing these panels is to take a thin saw and saw the grouted joints between each tile, and then basically use a low pressure pneumatic drill and lever the tiles off the wall. And this gives you 2 problems. The first is that you might break quite a few, and typically, even if you're being very careful, depending on how well they were stuck, you might break 50% of the tiles. But also you've got to document them very carefully. And if the tiles are bonded, then you can only cut one way, not both ways. So we developed a technique that enabled us to take these off in one piece. And the technique is based on this sort of schematic diagram here. So if you think of this as a planned section through a wall, so here's the brick wall, and here's the plaster, and here are our tiles, and that stuff remains set. Then we come along and, and we put on a reversible layer of paralloid bit 72 and woven glass mat. The trick there being the fact that it's reversible. So whatever we've done will do no damage to the tiles. We know we can undo it at the end of the process. And then we come along with a very firm, stiff piece of plywood, which we stick to our paralloid glass mat with polyurethane foam. Then the next step would be to cut down behind all of that. So at this point here, we'd set up a diamond wire saw and slice down the back of the tile panel. That's not terribly clear. Hopefully a few photos will show you how we went about it. So here is our trial tile panel. The very first thing we do is to check it to try and make sure that there aren't any additional paints on there. So sometimes these things were touched up with ordinary paints rather than fired ceramics, in which case we wouldn't want to risk pulling them off or destroying them with our reversible processes. And then we applied our glass mat, which you can see here. And here it's just being wetted through with the paraloid B72. And in this case, it was acetone that we were using. And there's the panel completely covered in a glass mat. Dotting on a few spacers so that the plywood, stiff plywood, stays reasonably well away from the surface of the glass mat. And that's the tile pan, the plywood, the very stiff plywood that we're going to use. And in this case, we reinforced it with some sections of aluminium, although we didn't need to, we discovered we didn't need to do that. This was only the trial one that we're doing, and the plywood itself eventually proved to be stiff enough. And here you can probably just see there's the foam squirting out. So the plywood panel has been screwed back to the wall. Here, the foam is squirting out through the side, so it shows we've got a full joint. Having done that, we then go around it with this machine, which basically cuts a chase into the wall. It's the sort of thing that electricians use if they want to run some cabling up here. In our particular case, what we wanted to do was to go all the way around our glued on panel, and that we could fit our diamond wire here. The crucial thing to note about this is, and I'll go back a picture, it's the positioning of this pulley wheel here and this pulley wheel here, because they will pull the wire downwards. So this handle is screwed round and round and round, and it pulls this pulley in that direction, which pulls the wire down. And this wire will cut through just about anything. So as long as there's nothing of a different hardness in the way, it'll come down pretty much straight to where the pulley is. In our particular case, as you can see here, there was a conduit that narrowly missed us, which was lucky. In a couple of other places, the conduit wasn't there, and the wire tended to go round as well as through the steel work. So we had to develop ways of keeping the wire back because we didn't want to damage our tiles. There's the machine working away. You can see it's a very messy process. So you wouldn't be wanting to do this in a kind of museum or an art gallery, but since this hospital was being demolished, it didn't matter too much. And there's our panel taken away. So it's finally released from the wall. And that's what it looks like. You can just about detect, I think, the curves of where the diamond wire worked, and gently worked that way until it was all the way through. Roughly packed for transport back to Telford. And here in Telford, we're using a laser controlled diamond cutter to just remove the remains of any brick and plaster that is left behind the tiles. This is the sort of machine that people use for doing granite kitchen cabinets and kitchen surfaces and things like that. There's the back of the panel, and you can see no damage to any of the tiles. The tiles are now pretty much clean and just ready to be glued back onto yet another piece of plywood. In this case, though, it's going to be the piece of plywood that will be its backing for future display. Here we are in the workshop reversing our process. So here's the plywood that the tiles have been glued to. There's the line of tiles you might just be able to see. And here is foam and plywood. And for this process, we are using what we rather grandly called the infinitely resharpenable saw. In other words, it's a piece of knotted string that we use to cut through the foam. We didn't want to use a steel blade for risk of damaging the tiles. And that's the original piece of reinforcing plywood taken away. We thought we might have to reverse this process using chemicals on here. In the event, as it turned out, the amount of adhesion of the paraloid was just about reversible, so we could pull it off by hand, which saved an awful lot of chemical use. And that's the final panel mounted in its stainless steel, and some of these are now on display in the new hospital in Newcastle on Tyne and Son. Some are in general store. just a very quick one on this, just to show you how joyful our Victorian counterparts could be. This is a bandstand from a few years ago, in looking very sad and needing some repair. We were called in to look at it, and we took some paint sections, and very often on these old things, if you get into a corner somewhere, you can usually find paint that's been going on for many, many years. And here we found 15 different layers of paint. And based on the analysis, we were able to determine that the Victorians had painted it something not dissimilar to this, which I hope you agree is very cheerful, and certainly people enjoyed it at the time. Something mundane. This was a project that we had to do for British Waterways when British Waterways existed. It's now Canal and River Trust, obviously. And they got into an argument with English Heritage because English Heritage said that this should be reused. All the engineers amongst you would probably think, well, those threads don't look very, very strong, actually. Something's not quite right there. We don't think it should be reused. They couldn't agree. So as a freelance conservator, we were called in, and we simply suggested, and this bolt was part of a set holding a plaque onto a bridge, that we simply cut a small recess in behind the plaque and lodge that there for future reference. So somebody in the future may well find it and work out what it was for. British Waterways, in this particular instance, got into a bit of a row with caddo, in this case, not English Heritage. And again, we were called in to kind of try and play umpire. And it transpired that the main argument appeared to be whether this was a bridge or not. And British Waterways essentially wanted to treat it as a bridge and was spending an awful lot of money. The scaffolding on this was £440,000, probably 20 plus years ago. They have a legal right to do whatever they want, really, because they have government permission or indeed instruction to look after these things. But caddo, of course, no, it's a scheduled ancient monument, so like to be involved. Anyway, sense prevailed in the end. Most people won't know that there's an owner of a bafta who lives in Ironbridge. He's a friend of mine. He's also a very friendly guy and lets people pick his bafta up. And it may not be obvious, but this part of the bafta is very heavy compared to this bit. So more than one person picked it up and then proceeded to drop it. So we had a little job to straighten the bafta, and I think after that it was not handled quite so readily. Here is another, on the one hand, mundane. It's a fantastic piece of corrosion, and in fact there was around about there was the top of the base of a statue. So this was a holding down bolt for a statue, bronze statue. And I think this is the best example I've ever seen in my profession of galvanic corrosion. So below it, luckily it was just about strong enough for us to be able to undo the nut. But it wasn't a mundane piece. It was a holding ornament on this, which is part of the Albert Memorial. In fact, it was holding down one of these statues. I can't promise it was this one, but it was one very similar in this position, which was probably about 50 meters up in the air, so you wouldn't want it falling off. But the Albert Memorial, which was a major piece of metalwork engineering, was interesting to do because of its intricate detail, but very boring in the sense that the Albert Memorial from here upwards is basically, all of this is a lead covered cast iron structure. It's a highly ornamental covering, but that's all it is. From an engineering perspective, there's a wrought iron cruciform beam that runs from that pillar to that pillar and from that pillar to that pillar. And all the rest of this is basically balanced on top. Quite a lot of it isn't really fixed. It's just sitting there by gravity. Nevertheless, it was a phenomenal piece of work to be undertaking. And when I say it was intricate, I mean, here's a kind of boring piece of ordinary lead cladding. Here's relatively boring lead tiles. But here there's glass, gilded lead, although that hasn't been regilded, but all of this has been regilded. There's gilt, copper and bronze decoration. So a stunning piece of Victoriana. if you like that sort of thing. The railings around it, which I can just show you, wrong way, run round here, were treated at the same time that we treated this, which is about 30 years ago. The railings lasted less than 5 years before it was discovered that the contractor who'd done them hadn't cleaned them properly, and all the iron started to blister. So we were asked to use conservation techniques rather than ordinary painter decorating techniques to deal with it, which we duly did. The art, of course, is how much you clean. So you've got to thoroughly clean, and then modern paints will give you a decent life expectancy, particularly when there's that amount of gilding on it, because gilding is about the longest lasting finish that we've got even these days. We're not always so heavy-handed. So here is the Divinity School having a very gentle brush with a soft paint brush and a hoover to pick up the dust. Similar work done on the Birmingham Town Hall organ, although in this case, as well as gentle brushing and hoovering, I think there was a bit of swabbing with some deionized water, as there was here. And this is the American Aircraft Museum at Duxford. You can see that most of these aircraft are pretty much pristine concourse condition. You can't walk on them, you can't stand on them. The main difficulty, apart from making sure you're careful, is to work out how to get your cherry picker in there so that you can get on top to do your cleaning. One of the problems with aircraft museums, and indeed many transport museums, is that they're very fond of getting things back to concourse condition. They like them to look pristine, whereas more modern curators and conservators, particularly since we like minimum intervention, are less keen on concourse condition and prefer the object to tell its story. However, this is a picture of Miss Britain 3. Miss Britain 3 was our most oft visited part of our website many years ago. We think probably because we think people were probably looking for soft porn, not for an object like this, which in fact was the holder of the water world speed record between the wars. It's owned by the National Maritime Museum, and contrary to what I said earlier about museum curators wanting something to tell the story, they wanted this to be virtually a sculptural display. So we were encouraged, indeed instructed, to polish it and make it as close to its original condition as we possibly could. There's no way on earth that it would ever have achieved this when functioning. It probably would have flipped over, and the person driving it would have died if it had done anything like that. It's designed to stay as flat as humanly possible on the water. This one did just take a clean. This is a South African 15F. It's a massive locomotive, and it's in the Riverside Museum in Glasgow, again to our Scottish visitor, if he has the opportunity to look at it. The thinking behind this is that the idea was to make this locomotive look exactly like it did the day that it rolled onto the scrap line in Bloemfontein. So there was a series of these that were taken out of commission, and they were on their way to China actually to be melted down. And they spent a couple of years on the scrap line waiting to be taken away, at which point they built up a bit of dust, but nothing too terrible. The main thing that happened was that all of this copper work was taken. So when it came to the UK, our job was simply to give it a good clean, take out any oils or so on that might be corrosive, and replace the copper work. Very much the idea that anybody who had taken that locomotive to the scrap line would look at it then and think, yes, that's what it was like the day that it retired. This one's slightly different, El Clingo. This is a piece by Ernesto Salmeron, who's a Nicaraguan revolutionary artist. These particular trucks, in fact, I am told, were the most populous truck in the world at one point. They were made in East Germany, tough as old boots, four-wheel drive lorry, that were given in their scores of thousands, if not tens or hundreds of thousands, to any revolutionary organization around the world. This is during the time of the Cold War. and this one ended up in Nicaragua. And it was taken over by Salmeron to represent the struggles, the revolutionary struggles of South America. It's had some stonework with graffiti in the back. There were crisp packets on the floor. There was an old tire in the back. It was bought by the Tate for a huge amount of money, brought back to this country, and we were told to stabilize it. So basically we had to lift it up in the air, remove any oils and acids and so on, provide support so that it didn't have to sit on its tires, and basically try and make sure that it wasn't going to degrade any quicker than it absolutely had to. And we sent it off to the Tate, which is where it is, just prior to going on display, so it isn't quite on its support yet. However, excuse me, it was decided it should go out on loan. There was an exhibition in 3 different cities in South America, so it was duly packed up by Montmartre and shipped to South America, where it was on display. And then it was decided to cut the exhibition. So it was coming back from its first destination, which meant that there wasn't anybody there to sort out proper international travel for a work of art. So it arrived at the docks with instructions to treat it like a work of art, which nobody believed it was. So it came back to the UK as deck cargo. And needless to say that all of those careful things like crisp packets and so on had disappeared, and it was a very, very salty and obnoxious thing that was finally returned to the poor old Tate. It isn't only transport people who like pristine condition. This is a picture of Waddesdon Manor, I believe taken in 1908 from Country Life, and it shows this piece of ornament on the roof line. When we went to look at the job, that wasn't there, but the architect had persuaded the owner that it needed to be replaced in order to restore the balance. Luckily, we had 1 or 2 small pieces in order to give us a hint as to what it looked like. So we arrived at a design and were instructed to make it. The main part of the top is a cupola, a lead-covered cupola, which is obviously formed by this. And here's the various bits of element fastened to it that we agreed between us was going to look appropriate. This is in its just about being returned. And there it is now. I think you can debate whether or not it's worth it. This took place probably 25 years ago and cost more than the price of an average UK house. This is another Divinity project, actually. You probably all recognise the Houses of Parliament. We did all the investigative work on the roofs, and that particular photograph was taken stood on overlooking Speaker's Court. And the roof at the Palace of Westminster is basically made of cast iron plates of roughly a metre square that sit down onto wrought iron angles, which worked reasonably well up until the point that there was some damage in the war. There was no direct hit, but there was some damage in the war. But also the sheer weight of these cast iron panels was causing some movement. We basically did a feasibility study for them as to how we could treat the stuff, which once you've got them off actually is relatively easy. The difficult bit is getting them off, particularly working in a place like that where the MPs are very, very touchy about noise and so on. And so it's a very, very difficult place to work in. However, there seems to be some agreement that the overall project is going to go ahead. So some of the roofs have been done. Big Ben is virtually being completed as we speak, I believe, and we haven't been involved anymore. And they're planning the rest of the multi-billion-pound work to take place in over some years to come. I'm going to finish with the consideration of 2 projects which have a little bit more engineering in them. This one is the SS Great Britain, and this one is Fort Brockhurst. SS Great Britain is owned by a museum, and Fort Brockhurst is owned by English Heritage. Both had conservation management plans, both had a very, very serious consideration as to how they should be treated. but they both had very, very different needs. SS Great Britain had to function basically as a museum object, and Fort Brockhurst Bridge had to function as a bridge. And this meant that the forms of treatment chosen, even though they were very, very serious conservation projects, the forms of treatment were very different. So if we get underneath the bridge, this is the sort of thing we can see. So here is obviously very, very corroded wrought iron, the cast iron deck plate above, not so corroded in fact, doing quite nicely, and very often we find cast iron behaving much, much better than wrought iron in terms of corrosion. Here again, quite worrying, lots of rivets popped. Here, some obvious signs of incrustations of salt, which particularly if they're chlorides, are not good news for those of us who are looking to stop rust and other forms of corrosion. And here you can see a sort of general degradation of the ironwork. And I've moved from underneath the bridge to inside the ship here, but you can see that the kind of problems that need to be dealt with are very, very similar. So as far as the bridge is concerned, you can see that it's obviously given some worry to engineers for many years. Concern was obviously expressed about the bottoms of the stanchions, or these ugly concrete blocks had been cast around them to try and stiffen them up. Some movement on the bridge had been experienced, and there was quite an elegant solution put here and here in terms of some form of acro prop that could offer support below, but clearly not enough. So then this extremely inelegant scaffold was later provided. This bridge has to function. It needs to be able to take fire engines. It needs to be able to take lorries. Fort Brockhurst itself is a store for English heritage, so it needs to be able to take the lorries bringing stuff in and out. So clearly it was decided that something better needed to be done. So we were told to take it away, dismantle it and take it away. Luckily, quite a lot of it could be done with our own truck mounted HIAB. So it was, which has the advantage of being cheap and relatively delicate, because we as conservators are controlling it ourselves. These things were made as a sort of prefabricated kits almost. The Victorian Army engineers built lots of them around the world. I think they were pretty slick at it. So it comes in pretty much in kit form. Although when you're doing it with your own HIAB, it feels a little bit much like you're cutting off the branch that you're sitting on. So sooner or later you have to stop and get the crane. The first elements that we took were mainly cast iron, but you can see here the wrought iron beams that, from an engineering point of view, probably constitute the kind of heart of the structure. And these clearly needed to be removed by crane. Obviously, everything needed to go back in the right place, so we were documenting them. In this particular case, we didn't get up to huge numbers, but we have been known to get up into the scores of thousands when dealing with glass houses and so on, where everything needs to go back in the same place. I say most of it had to be taken away because the lower part, which was cast iron that went down into the moat itself, was first of all a bit difficult to remove. Secondly, we didn't know how it was fixed. Thirdly, as I mentioned before, cast iron tends to be relatively resistant to corrosion, and there's not a lot of corrosion obvious around here. So it was decided that these will be treated in situ and cleaned by ultra high pressure washing. I'll deal a little bit more with ultra high pressure washing later on when I can show you some better examples. But here is the final thing. We've obviously removed the cofferdams and reflooded the moat. I gave a talk to the Institute of Structural Engineers a short while ago, and as luck would have it, an engineer from Fort Brockhurst was present in the audience, who happily informed me that it was all doing very nicely. Thank you. Back in the workshop, we used a different cleaning system. So here we're using air abrasion or shot blasting. In our particular case, we tend to use relatively low pressures, so somewhere between 50 psi and 100 psi, and a very low weight, soft, expendable blast medium. In this case, we use crushed garnet. It's relatively cheap, and it doesn't hack away at your metal too much. Our basic aim is to remove paint and rust and leave as much as humanly possible of the original metalwork in place. Paint manufacturers often say they like to have a good serrated surface and would use chilled iron or something like that as a blast medium, but they're happy enough with the process that we do, and they don't alter their guarantees for whatever guarantee from a paint manufacturer means. Of course, there's always a discussion to be had around that. In this particular case, and one of the main differences between this and the ship was that we were going to metal spray the elements. So the debate is always, how long is your finish going to last when you're dealing with these kind of projects? Obviously, the amount of expense and disruption caused to the bridge and indeed to the fort meant that English Heritage wanted it to last as long as humanly possible. So they opted for metal spraying. Metal spraying itself is a process similar to galvanizing. Instead of electroplating or hot dipping, you spray metal dust within a flame, a little bit like paint spraying. One of the issues about metal spraying is that you need to clean absolutely perfectly clean. There can be no rust or paint or anything left, and that's known as SA3. Cleaning standard SA3, whereas for painting we normally only clean to SA2.5, which is allows some remaining specks of rust to remain. There they are painted. Obviously the paint doesn't always last as long when you're on some kind of metal surface that hasn't been shot blasted, but therein is the compromise. The metallic protection that you get below is deemed to be worthwhile. We did have one piece of cast iron that came back to the workshop, and this was the support for a faked drawbridge. You can see it's broken. However, we did have all the bits. So having done some die penetration testing to look for other fractures, we were able to piece it back together like a jigsaw and fit it all back together. This isn't it. This is just an example of the method used, metal stitching. And you might be able to see here that basically you hammer these combs, as we call them, into sort of pre-drilled holes that are chained together, and these are hammered in such that they almost act like rivets. They swell out and stop any kind of movement outwards, as it were, in that direction. These are drilled and threaded holes into which are screwed studs, and they will stop up and down movement and the form of the whole structure, as well as the combs, stop it moving in the third direction. And it has the advantage of not requiring welding, and welding, particularly on old cast iron, is not an exact science, and very often you find that you build in more stresses than you're trying to cure, and the thing cracks slightly differently or just along the line of your weld. So although this is somewhat intrusive in the sense that we're having to drill holes, at least it's all very measured. And indeed, it was a process that was well used, very possibly in the agricultural section after the Second World War, when things were in short supply, and things like low pressure boilers or oil sump tanks and that kind of thing needed to be repaired. And this technique would give you a low pressure waterproof system without too much trouble. We also had these sorts of problems to look at. And where we had that, the engineers basically said, well, as long as it's a small amount, you can weld it. So we basically filled up these areas with weld and then dressed off back to the original shape. The main thing that we had, though, apart from the webs, were these plates that make up the tops and bottoms of these I-beams. And you can see here how they were constructed. So this is the top part of the beam, and there's what we refer to as plate number 1. Plate number 2, a bit bigger, a couple of angles, and then the web, which went all the way down to the repeat of this part underneath, and then the whole lot riveted together. And it was decided that because there was quite bad corrosion on this, was a plate 1 that was deemed to be not suitable for reuse, was going to have to be replaced, as would plate 2. But if we were to cut along this point here, we would actually turn this corroded plate 2 into a plate 1, because that's exactly where plate 1 sat on top of the plate 2. So here we were able to simply change the use of a particular piece and replace that piece of wrought iron. Unfortunately, you can't get wrought iron of sufficient quality and quantity, so the new plate 2s below had to be made from mild steel. So here we're tacking the new plate 1 onto the top of a new plate 2. You can see it tacked in place, and then drilling the holes in exactly the right place to be later riveted. And here they are, having been metal sprayed. Now, one of the problems when you've de-riveted something and you're re-riveting is that the rivet holes never perfectly line up. There's always been some stretching and movement of the material. So you have to basically bolt it together like we've done here, every other hole being bolted. The holes are then reamed out so they're perfect for riveting. If ever you get involved in this sort of thing, beware. We thought we were dealing with 1/4 inch rivets, sorry, 1/2 inch rivets when we came to tender for the job. It turned out they were 3/4 inch rivets, and it's probably 4 times as difficult to use a 3/4 inch rivet as a 1/2. So here you can see us beginning to do it. Basically, this machine here is going to hold the rivet in place while the riveting takes place. So this lever is flicked and it holds that rivet very, very firmly against the ironwork there. This is a second machine that comes along and actually does the riveting on the other side, so that the head is formed. It can't move anywhere, and you've got a perfectly formed rivet head once you've done the calculations to make sure you've got the amount of volume correct. Anyway, we had quite a lot of those to do, but there's the finished beam, of which there are many, and you can see it just about fills the length of our workshop. Back on site, we were rebuilding. Here's our bridge support, drawbridge support that's been nicely metal stitched, putting back our deck plates. And there's our finished bridge. And you can see that all of the inelegant support structures have been removed from below. None of the concrete blocks around the stanchion were needed anymore. There is, unfortunately, or fortunately from a safety point of view, the insertion of some grid there to stop children falling through. So you can see that was a fairly intrusive form of treatment. I mean, it's not something that we've done to that extent on any other project, actually. But at the opposite end of the spectrum, here we have the SS Great Britain. Now, when I first visited SS Great Britain, she looked like this, in fact. So this was the aft of the promenade deck, which was the most popular place to get married in Bristol, outside the registry office. It looks to be in really, really very nice condition. But upon looking deeper into the ship, I don't know whether you can see that, but it's actually a scaffold clip. The Victorians didn't have scaffold clips, so that scaffold clip was dropped into the hull of SS Great Britain, probably in the 80s, and I was looking at this probably in the mid-90s. I don't view that as a scaffold clip. I view it as a corrosion coupon, and that's showing me that there's a simply horrific amount of corrosion taking place in the lower part of this ship. Quite horrifying if you think of that as being about 15 or 20 years worth of corrosion. If looking underneath, and this is the fake keel, you can see again there's obviously some movement here. It's not clear whether the keel's moving down on the keel blocks or the keel blocks are moving up against the hull. It turned out it was a bit of both, in fact, but at that point in time we couldn't tell. So what were we going to do with the SS Great Britain? Well, she was a museum object. She had received massive funding from Heritage Lottery Fund. So obviously to do nothing was not going to be a sensible option. Shipyard style treatment was very interventive and much closer to the sort of work that we did on the bridge, but so far had proved to be unsuccessful. The various other treatments, which are much, much closer to standard museum style treatments, were not really appropriate for the ship. And other ones were kind of either impossible kind of to achieve in terms of environments or unacceptable from planning point of view. We did our best to sort of graph the outcomes that we were considering. So here's do nothing, which means that the ship was likely to begin to suffer catastrophic failure within about 25 years, to these up here. And these were the ones that obviously are more likely to be considered for a museum object. The one that we chose in the end was dehumidify with a modified waterline plate. But before we could do that, we needed to increase our understanding. And I was quite surprised that when I first went to look at this project, that we as a profession didn't know at what relative humidity salty iron might be stable. Obviously, any ship is likely to have salt in it somewhere. And so we were interested in the response of ferrous chloride and iron to a relative humidity. And luckily, the Heritage Lottery Fund were happy to pay Cardiff University to do some research for us. So they basically put amounts of iron filings with ferrous chloride into a dehumidification relative humidity chamber at various relative humidities and see when the weight of these iron filings became stable. And this graph shows that it was round about 19–20%. However, ferrous chloride isn't the only problem. We've got beta ferric oxyhydroxide, or acagonite, as some of you may have heard of, and it's much more aggressive than ferrous chloride. So the test there showed that we needed to think in terms of 12 to 15% in order to have stability. And that means your dehumidification system is going to be much, much, much more expensive than if you're holding it at 20%. However, it was also known at this point that acagonite, when it was washed in deionized water, or certainly not salty water, became stable at probably about 20% humidity. So here you can see what washed behaves like. The SS Great Britain had been subject to 30 years of Bristol rain. So it was in its dry dock. It got rained on, but it certainly didn't get any salty water anywhere near it. So we decided that we would design a dehumidification system to operate down to 15%, but run it at 20% and monitor what happened. In the event, it appears that we haven't had a problem with acagonites that we've been able to discover anyway. So how are we going to achieve this? Well, the idea basically was what became known as the glass sea. So here's a representation of the SS Great Britain in her dry dock. And the idea was that we were going to put a glass plate between the walls of the dry dock and the hull of SS Great Britain and seal it. So everything below would be completely dry. The inside of the ship will be completely dry and therefore available to be subject to dehumidification. So in the event there was a dehumidification plant built into the dry dock, which did all of the hull outside, and another one was put inside the ship that did all of the interior of the ship. This left the area known as the top sides to be treated conventionally, which is the bits that we did. This was the kind of thing that we were faced with, though, and because it was a museum project, we didn't want to lose any of this. We kept all possible original material apart from the rust. We needed to remove the rust to make sure that our patches and our painted finish could adhere well. This is the cleaning that we did initially. So to start with, we debated the best way to clean, took various advice from various people, determined in the end that it was going to be low pressure shock blasting system that would clean everything away, but retain all of this very, very frail metalwork, which meant that we had to do it very slowly and very carefully. Of course, when you've done that and you're in the outside air, freshly cleaned iron begins to rust fairly quickly. So all of this is now covered in orange flash rust. However, That's very easy to quickly remove prior to painting. It doesn't take very long. There was a big debate taking place amongst the profession about this, because some people believed, certainly those who worked on ports and so on, that it was a good idea to clean and then let rust form and then clean again prior to painting, because they somehow believed that that's removed or sucked out some of the chlorides that might be hiding in your metalwork. Scientists in Manchester poo-pooed the idea and said there was no such evidence to prove that. I have no idea which is right, to be perfectly honest. All I know is that our cleaning method, because we had to retain this very, very frail material, involved us in allowing it to rust and then cleaning. So that's what happened here. And so far, in fact, the paint is adhering very well. So this is when it's had its primer, and you can see this is very, very fragile. These pieces are being bent slightly, but all we needed to do was to put a bit of a patch on. So it could be a simple smear of epoxy resin like this, because its only job is to keep the wet air outside and the warm, dry air inside and hold a film of paint. It fulfills no structural purpose whatsoever. Even in bigger areas like this, where unfortunately they'd introduced polyurethane foam. A kind donor had given a load of foam, and they thought it'd be a good idea to support the bow area, without really understanding that they were going to build a pretty unpleasant microclimate that just rusted everything away. So that needed much more significant patching. And so here, instead of a smear of resin, we needed to use glass mats to support it. But again, you can see it was a very, very thin layer that was required, just simply to hold paint and to keep the moisture at bay. We did some structural repair or strengthening, but because it was a serious museum project, we were not allowed to weld or drill any of the structure. We could only pick up existing holes and then use clamps and struts. So in fact, we fitted eventually 144 of these pieces throughout the ship, which were designed in small enough pieces to be carried down into the hull and then bolted together in place. The engineers in charge had a very, very elegant computer model, and they would come along and we'd agree a sketch between us, design it, fit it. They'd come back, analyze it, fit that into their model, and then we do the next bit. And so far as I'm able to tell, that's proved to be highly successful and a wonderful working relationship between conservator and engineer. This is ultra high pressure washing. It's about 50,000 psi and has the great advantage that it will remove rust and it will remove paint, but it won't remove any metalwork. As long as the metalwork itself is physically strong enough to resist the pressure, it won't be eroded by pure water. And this means that we could use ordinary contractors to clean the bulk of the ship. We did our delicate bit of cleaning, which was probably about 20% of the area of the ship, and it took us 3 years. And it took these guys it was slightly more than 3 months to clean the rest with UHP, ultra high pressure washing. And here you can see, this is where we've cleaned. The very, very light grey is the effect of air abrasion. And this area here is the effect of ultra high pressure washing. They look very different, but the paint manufacturers are perfectly happy with it, and they regard that as a suitable standard. So this is cleaning to SA 2.5, and this is cleaning to HB2, which is hydroblasting grade 2. So again, a very, very appropriate system. It's quick, cuts down dust, causes no damage. So it has many, many advantages. While we were doing this, we came across these stamps. You might just see that says BDAL. And here there's one that says BDAL, crown symbol, and BEST. And those are signs of Coalbrookdale Best wrought iron. And prior to this discovery, there was only secondary documentary evidence to suggest that the plates came from Coalbrookdale. And by secondary documentary evidence, I mean it was recorded in the proceedings of the Royal Naval Institute's proceedings that the Aaron Manby, open brackets, the first iron ship ever to put to sea, was made from cast iron plates from Coalbrookdale, close bracket, open brackets, as was the SS Great Britain, close brackets. And that was the only reference there was to these plates being from Coalbrookdale. Now we have it. You can't get better than a stamp on a piece of iron. And this is why you will very often hear conservators banging on about the importance of original material. That's why we want to keep it. That's why we want minimum intervention. That's why we want reversibility, so that stuff like that isn't lost, because quite a few plates on the SS Great Britain had been cut out as part of the shipyard treatment because they were too rusty to provide support, and who knows what information may have gone with them. Anyway, that's the kind of top sides finished. We still have one little bit more work to do, because as you remember, we've got to have this glass plate which fastens to the dock wall here and to the ship here. But of course it can't rigidly be fixed because both are going to move with expansion and contraction. So we needed some other form of fitting. And basically we designed this bracket, which is a piece of J-shaped stainless steel. This material is Hypalon, which is the sort of thing they make inflatable boats out of, and it's been around for donkey's years. And it's probably the best material, well, definitely the best material that we could find. So we were responsible for fastening these brackets to the ship. In order to be able to do that, we needed to make sure the ship was strong enough to take them all the way around. So we had to measure the thickness using eddy currents, because the laminations wouldn't allow ultrasound to be effective. And luckily there was enough so we could go, there was enough thickness so we could fit it all the way around. And then they came in to fit the glass plate, which you can see fitted here. So here's the supports, here's the glass plate, which is carefully designed to be able to take quite a lot of abuse from above, and without any breakage. And here's a photo that I took on my very first visit to the SS Great Britain to begin work. And I've got this because we didn't do a single piece of work down here on the structure itself. This is exactly as it was on the day that I saw it first, and this is exactly as it was when we finished. Obviously, we've got this ducting here for the dehumidification system. This is blowing out the dry air, and the dry air is collected up here in these and recycled round. The wooden props, which you can see here, have been replaced with these steel ones, which are adjustable. So it allows us to measure the load that each one's taking and keep it balanced. But it's really not very intrusive. I was a bit worried to begin with that it might be off-putting for people, but people barely notice it. So that's what you see now when you look from the bow of the SS Great Britain. And that's what you see when you look from the bow at the waterline plate. And that's it from me, and apologies for overrunning slightly.
Thank you, John. Yeah, no, that was, sorry, Robert, that was brilliant. Right, do we have any questions from the audience?
Just a comment from me, Tim. It seems amazing that there's enough money around to actually fund these projects. I mean, the amount of detail and time and expertise is just incredible that we're, as a country, able to afford that sort of thing. You got any comment on that, Robert, as to where the funds come from?
Well, it depends massively. Yes, I think there was more money around 15 or 20 years ago than there is now, for several reasons. One is that some of those projects were very heavily funded by the Heritage Lottery Fund, and that's got a lot less money than it has had then, in part because lots went to the Olympics and so on, and there's just less money available. I can give you another figure, actually, that on the day that we finished it, the SS Great Britain was going to run up a gas bill of about £70,000 per year, and that will be in 2005. So it's probably going to be a lot more now. And there's a big discussion about that. And when we planned that, nobody thought about carbon footprints. It was not on the agenda. Maybe it should have been, but it wasn't. I know now that they're seriously looking at the possibility of trying to use solar panels where the glass sea is, and do something electrical rather than using gas for the dehumidifiers. But it's a big problem. I mean, the 130-odd thousand pounds for that finial was at Wadston Manor, and I don't know whether you know or not, but Wadston Manor's the Rothschilds. So
Yes, yeah.
I guess, you know, it's these things are a bit relative as to what you choose is important to spend your money on.
Yeah.
But I don't have a kind of a definitive answer to such things. I think it's a question of how people view civilization in their particular society. So I'm very, very open to the argument that we should be spending money on social services and the health service and that kind of thing, not on conservation. On the other hand, there's stuff out there that even a little practice like ours has discovered that if we hadn't done it, would possibly be lost forever. Now, is that of major lifelong importance? I don't think we can say. And I actually don't think we know what's important either. That's another thing. I think fashion changes quite a lot and knowledge changes quite a lot. I had the good fortune to visit the terracotta soldiers many years ago on holiday. And I learnt there, which I hadn't learnt anywhere else, that there's a huge hill alongside where that site was that they know is absolutely filled with probably even more exciting treasure. The Chinese have decided to leave it where it is, not to excavate it, in the belief that in years to come, there will be techniques that will allow them to understand what's going on there without excavation. There are quite wonderful developments. I mean, some years ago, Tim West in Cardiff used the synchrotron to develop techniques to read on parchments when they were still rolled up in scrolls. The problem with parchment, it gets very, excuse me, it gets very brittle over time, and as you try and open it, it tends to crack and fracture. But he developed a technique for reading parchments through, leaving them completely rolled up. So without a synchrotron, you couldn't do it. So there are lots of great discoveries that we're making now by spending money, not necessarily in the way that was spent on the projects that we did, but with scientific development.
Yeah, so it has got a payback in a lot of cases.
Yeah, I think you're right. Yeah.
Tom Copeland, do you want to sort of come in and ask your question?
Sorry, I'm working with a very old computer that's got all kinds of glitches in it and an old head at this end as well. On the likes of the East German truck or Paul's MG or one of my old tractors, how do you arrest corrosion and prevent further degradation but still retain the patina?
Well, treat it like we treated the SS Great Britain is a short and rather silly answer in a way. There are several things that are likely to be going on with your old tractor. The most immediate, my guess would be the tyres. So they will become brittle. They will, if you don't take the weight off them, they will sort of sink and split and look pretty horrible pretty quickly. So I would certainly get some like axle props and take the weight off your tyres. Remove the pressure from them sufficient so they look okay, but they're not actually trying to do any work anymore. The next thing to look at would be anywhere where you've got oils, fuel, water and that sort of thing. So put your anti-corrosion stuff in your radiator, flush it through and drain it down. Do similarly with your fuel system and your lubrication systems. So try and get rid of anything that you think might have something in it that will promote corrosion in future. And most fuels have something in it that's when you get some water in there, is likely to form sulfuric acid or something like that. So try and get rid of those. And then the third thing would be to make sure you keep it in an environment where there's not too much moisture. When I say too much, that's a kind of difficult thing to quantify because it depends what other materials you've got apart from metal. So there may well be, I don't know, you might have a leather seat, probably fairly flashy for a tractor, but there may be some wooden elements, and all of these different materials benefit from a slightly different treatment technique. So typically most museums would keep their relative humidity, if they could control it, probably around about 40%. But as we saw earlier, that won't stop corrosion on salty iron. But if you go down to 20% and you've got wood present, if it's relatively new wood with moisture still in it, it'll dry the wood out and it'll shrink and crack. Now you can take steps to avoid that by trying to put some waxes in or something like polyethylene glycol, but it's only partially successful. So once you've got these mixed media things, it's very, very tricky. And then it comes down to, you know, how precious is your tractor? I mean, can it afford to be given its own environmentally controlled shed? And perhaps not. I mean, we've done some agricultural machinery, nothing as complicated as a tractor, but simple plows and so on, harrows, where we've just cleaned them and then painted them, and then they've been left to let nature do what nature wants to do to them. Similarly, for Ironbridge Gorge Museum, actually, there's quite a few big pieces that are above the entrance to Bliss Hill, which were just cleaned and painted, so made to look nice, not seriously believing that they're going to last in perpetuity.
Thank you. It is a problem to get the relative humidities down to the levels you're speaking of. We're lucky to get down to 60, just generally here in Edinburgh, even where we're on the east coast.
Oh yeah, I can believe it.
And the more expensive cars and so on, we use these air-conditioned cocoons. I can't remember what they're called. Just a big plastic bag in effect, and the car's driven in. And those work quite well, but they're quite expensive to run. And probably is better a dehumidifier, and we don't do that, but we put a little bit of heat in them. But you can justify that on a 1909 car, but you can't do it in a 1950s tractor.
No. And also, I mean, these cocoons, or what, I don't know what the term is either, they're not wonderful from a visual point of view either, are they? So there's a lot of compromises in these things.
That's right. It's fine if you're just keeping one or two, a large cocoon, and you can get around them. But it's an expensive way to do it. But then a thing like that is expensive anyway. Thank you.
Yeah.
Can I ask how you got in this business?
Yes, you can.
What did you want to do when you left school? You know,
I'm a shining example of it's not what you know, but who you know, I'm afraid to say. So I spent my early working life as a furnace engineer, and I specialised in a particular form of furnace known as a frit smelter. And we built these continuous frit smelters in various parts of the world, and very nice and exciting it was too. But we relied on the services of a couple of UK transnational consultancies to get the work for us. And there's certain amongst us who will remember the Arab oil recession, when OPEC decided to crank up the price of oil. And these consultancy services pulled their horns in a bit and stopped doing the kind of work that gave us our work. So in the mid to late 70s, I found myself sort of gently out of work, and some friends had moved into this area who one day came to me and said, "We've got just a job for you to apply for." And I said, "What's that?" And they said, "Deputy Keeper in Conservation at the V&A." And I said, "I'm a furnace engineer, I don't know anything about conservation." They said, "No, but you've got the right attitude. And we know the keeper in conservation, and he definitely wants the whole thing to become more businesslike." So I had filled in an application, which, as you probably know, if you want to go and work for the V&A, you're applying to join the civil service. So it's quite a kind of performance to get in. And since my friends were going to be my referees, I sent them a copy of the application form, and they promptly offered me a job. And I thought, well, I'll stay in Telford rather than risk going to London anyway. So, and they were basically in the process of developing the treatment of lead sculpture for the National Trust and the British Museum. and I went in there and sort of became their apprentice. And the rest is history.
Mm.
Very good.
Right.
Fascinating.
Yeah.
Good. Thank you very much.
When you are using the high pressure water treatment to sort of take the rust off, presumably it must leave a little bit of a layer of flash rust behind, is it?
No, because it can do. It depends how quickly you get on and paint. So because it's a very quick process, they basically used to paint at the end of the day. So they would paint it, let it dry, and we were using a particular paint system then, which was Lee's. They've been taken over now. They're called Sherwin-Williams, but the Lee's paints. And the chief technician for Lee's was very, very friendly towards us as an organisation. We always use Lee's paints. We've used thousands of litres of it over the years. And he came down and looked at what we were doing on the SS Great Britain. And he said, I strongly, strongly recommend that you use a particular primer called M111. He said, it's a bit more expensive than the others. He said, but it's a 2-pack zinc-rich primer that is moisture tolerant. So as long as it's not wringing wet, if there's a bit of moisture on the surface, it actually helps the curing process. So it's a 2-pack paint. So that wasn't an issue, actually.
Right.
It was an issue with our very, very slow cleaning process, but not with the ultra high pressure washing.
Are there any techniques that have been developed recently that actually would reduce or preclude deterioration of the sort of objects that you've been working on? Is there anything in improved manufacture that could actually sustain them longer?
The answer is not that I know of. Now, some years ago, an acquaintance of mine asked me to go and talk to the synchrotron users group at Daresbury, and she runs the Bartlett School at University College London, and she's very keen on kind of promoting science and conservation. She said, just go and give them your cheerful little talk about some project. They'll enjoy it, which people mostly do, well, present company hopefully included. And she said, but at the end of your talk, I want you to ask them for 3 things. Just think of 3 things that you can ask them to do, because there's, the UK's smattering of brilliant scientists in the audience here. Ask them. And so I said, what I would like, one of the things I would like is a invisible, reversible product that will stop corrosion. And there was complete silence in the audience. And then during the coffee break, a guy came to me and said, you should talk to somebody whose name escapes me at Queen's in Belfast. He said he's a specialist in ultra, what was the phrase he used? Ultra hydrophobic coatings. I said, what? He said, it's what it says on the tin, ultra hydrophobic coatings. I said, oh, right, okay. He said his party piece is he comes along and gives his talk, and then he's got a Hessian sack that he sprays with his material, and then he fills the sack with water. And he thought, that's bloody impressive. But as far as I know, there have been no coatings developed that will be useful to us. It's, it's just one of the other things I asked for was, is there any way that we could learn anything about the history of rust, so that if we were all in the room together now and somebody was murdered, we would have left enough DNA in there between us that the police could have a good go at tracking down who might have been there, who could have done it. 100 years ago or whatever, that couldn't have been done, could it? So science has made a fantastic advance there. So I said, is there any way we could work out the history of an object by analysing its rust? Again, nothing. So no, I was probably asking the wrong questions. But having said that, I mean, it's some years since I've been involved, but there's an organisation called CHAR, which is something like Science and Engineering and Art and Heritage, something like that. And they get serious funding. And they have a suite of PhD students who are doing fantastic work, and a lot of it's based at UCL. And they're going to come up with something sooner or later. I have no doubt about it, absolutely no doubt that things will move on. And it's not just stuff like ground penetration radar and all those sorts of things that are very, very useful to us now. There will be more that's coming along, and simple little things can, if we've got how are we off for time, Dave? I don't know what your sort of
well, it's purely up to you. I think people are still interested, and it's purely up to you.
Well, I'll tell you a story. I don't think this has been published. It was told to me by a scientist at a European Commission meeting. So you may know or may not know that in days gone by, people used to make their own ink by grinding up iron gall. It's one of the materials that they used. And it gives you this sort of browny, purpley kind of ink that you see very commonly on old documents. And some people in Slovenia, for whatever reason, I don't know, decided that they were going to start analysing iron gall inks. And that they did some of this and discovered that they could do quite sensitive analysis of the constituents of various inks. And around about the same time, they learned that apparently Galileo, who similarly to our Shakespeare was reputed to write everything down in one go, you know, rather than sit down, give it a bit of go and then go away and think about it and come back again. It was supposed to all flow out of it in one go, which everybody kind of doubted, but that was what received wisdom said Galileo did. Anyway, our Slovenian friends went and analysed some of Galileo's stuff, and Galileo apparently was a real hoarder. He never threw anything away. And one of the things that he kept was his shopping lists, and his shopping lists were dated. So they were able to analyse the ink on his shopping lists and then analyse the ink on his theses and prove that actually they'd been written over quite a long period, because they could use shopping list dating techniques as long with their. So, you know, these little steps forward are very enjoyable, and it's nice to have the reputation of people like Galileo put into correct context.
Very good.
On the early on in the talk, you talked about the sculpture with, well, the angel with the core material still in there.
Yeah.
Presumably that happens to be a very, very invasive technique.
Oh, yeah.
So presumably you're cutting open by some technique, and
yeah,
you're saying you're having to weld it back together.
Yeah, yes, if I'd have given you another talk about bronze sculpture, you would have understood some of the ways in which bronze sculpture can be put together. So very often they're made in various pieces that are fastened together by what's known as Roman joints. And if you can think of something that slips over very neatly and then you pin through. So when you see a corroded statue, very often around the neck, for example, you might see a series of studs showing just like a little round circle where it's a different material because it's a stud that's been screwed in rather than the cast material that's around it. So it corrodes slightly differently and you can see them. So in an ideal world, we then might unscrew those and then take the head off or the arm off or something like that and gain entrance that way. In that particular case, we couldn't. We had to basically take the angle grinder to the body and cut a panel out so that we could excavate everything. And if you might recall, down the shin of the, because it wasn't hollow inside, we basically had to chain drill a series of drills at angle to each other so that we could then lift a panel out. So very, very intrusive.
And presumably it's then just a case of welding it back together and then sort of getting the original form, original shape back where you put the weld in.
Yeah, so basically you just you very carefully put whatever you've taken out together so it's in the right place, tack it in place, make sure the profiles are right, and then just fill your gap with weld and slightly higher, then dress it back down to the level surrounding.
Another thing you mentioned about wrought iron, obviously on the bridge you couldn't get enough wrought iron there. If you're doing smaller objects, can you still get hold of small quantities of wrought iron, or is it a case of trying to find old scrap wrought iron and using that?
You can get some wrought iron. It's mainly re-rolled from old anchor chain and things like that that have been found. So things like anchor chain were made with, and I said that SS Great Britain was made with Coalbrookdale Best. Well, that's a bit of a misnomer, really, because that's not the best quality. Triple Best would be the best quality. So things like anchors will be made with Triple Best wrought iron. And Triple Best basically means, the reason it's called wrought iron is because you take the iron out of your furnace and you wrought it, you hammer it. And there are videos around, actually from Bliss Hill, you can see them, where they take this stuff, they put it through the hammer, and you can see sort of the various slag and so on is squirting out through the laminations of the wrought iron. And so they hammer it into a shape, and then they might put it back in the furnace again. And then if they put it back in the furnace again, then take it out a second time, you squeeze out even more of this flux and slag. And that will be double and then triple best. So if you look at wrought iron, and in fact, the way to tell wrought iron, because very best wrought iron, high quality wrought iron, is very difficult to tell from steel just by looking at it. But if you can cut it and then cut a bar halfway through and then snap it, you can see a sort of fibrous layers. So all of the slag and inclusion that's in wrought iron gives you this kind of lamination effect. And poor quality wrought iron looks like, when it's corroded, it looks a bit like a piece of wood that's been washed up on the beach, where sort of the soft parts of the wood have been eroded.
Oh, right, yeah. So yeah, so yeah, you've sometimes been on a beach, you find bits of metal sticking out of something.
Yeah.
Into harbors and that sort of stuff.
Yeah. So yeah, so people will take like chain, which can be, you know, it can be quite thick, and they'll hammer that down and roll that down. As there is an organisation that collects wrought iron and processes it, but it's a fantastically variable quality. There's no way on earth that any engineer would agree to have it put on a bridge that needed to, you know, function as a proper load-bearing bridge, because the quality of the wrought iron is just too variable. So for things like a bit of a repair on gates and railings, then yes, you might be able to find some wrought iron. But I think there's also an argument to say, well, does it have to be wrought iron? You know, you wouldn't be able to tell whether it was wrought iron or not. So when the gate was finished and painted, you wouldn't know that it was wrought iron or mild steel, or indeed pure iron. So you can buy pure iron now in various sizes, which is quite close to wrought iron in terms of its chemical quality and its workability. It's much softer to forge than steel. Although, you know, lots of people do fantastic wrought iron work with steel these days, so it's not a game stopper if you have to use steel. So there's a sentiment around wrought iron, but it's problematical, and it's not being made anymore. It's definitely only, well, it's made in lab quantities, but it's not. You can't go out and sort of buy it certified off the shelf like you can steel or iron.